Okay, so when a reaction takes place then, we usually like to say that it can be either exothermic or endothermic reaction. And really, again, if you look at the makeup of the words, if you're not sure, think of therm, so obviously that's to do with heat. But the way I always remember this is, if you think of exiting, it means the heat is exiting, it's leaving the reaction. So it means that if you carried out a reaction in a beaker and you put your hand on the outside, the beaker would feel hot because the heat energy is leaving the reaction. Whereas with the endothermic, I always think of entering, so that means the heat energy is entering into the reaction. So it means that if you had your hand on the bottom of the beaker on the outside, it means that it would cool down. Now, combustion is an exothermic reaction because energy is released during the reaction. Exothermic reactions transfer energy to the surroundings, usually as heat, and this can make exothermic reactions easy to spot. If the temperature of the reaction mixture and its container goes up, the reaction is an exothermic one. And you must make sure you use that terminology if you're given an exam question asking you to describe what's going on. Exothermic reactions can also transfer other forms of energy to the surroundings. For example, explosions release light and sound as well as heat. The reactions in batteries release electrical energy when the battery is connected in a circuit. So there's at least 3 examples there that I've talked about in terms of exothermic reactions. Now, if we look at endothermic reactions, they take in energy during the reaction. They absorb energy from the surroundings, usually as heat, and if the temperature of the reaction mixture and its container goes down, the reaction is an endothermic one. Sherbet sweets feel cold on your tongue because of an endothermic reaction between the sodium hydrogen carbonate and a weak acid such as citric acid. An endothermic process happens when ammonium nitrate dissolves in water. The temperature may fall so much that a drop of water can freeze the container to a block of wood. Endothermic reactions can also take place in other forms of energy from the surroundings. For example, electrolysis is an endothermic process. Electrical energy is absorbed to decompose a compound. Photosynthesis is also an endothermic reaction, and you should know a good couple of examples of each. Now, if you look at it more closely in terms of what's going on with the chemicals, it's all to do with the bonds that chemicals make, and the bonds that are formed during with the reactants are broken down during a chemical reaction, and new bonds are made as the product form. So bond breaking is an endothermic process because it takes in the energy to break it down, whereas bond making is an exothermic process because it releases energy. Now, you may be asked to actually describe an experiment that you could carry out to compare fuels and to decide whether it's an exothermic or an endothermic reaction. And a good one is using something called a calorimeter. Now, a calorimeter is basically a copper pot, and it's good because it's such a good conductor of heat energy. It means that you are actually getting most of the heat energy from your fuel into your water, for example. So you might decide that you've got a couple of fuels, and if you remember, you might have done some experiments with the little spirit burners with ethanol in or propanol or something like that. So if you were asked to describe an experiment, you'd have a little spirit burner underneath a calorimeter, and there would be a thermometer in the water, but please make sure you have the same amount of water every time because you're making it a fair test. So you would time how long you would burn your ethanol for instance, take the temperature at the start, take the temperature at the end, then you would do exactly the same thing, start it all over again, same amount of water, take the starting temperature of propanol for instance, and then the end temperature, work out the difference between the two, and that gives you your temperature change. You can now put all of that into this equation, and I'm fairly sure they give you this equation. It's to do with specific heat capacity, if you remember in the physics topic. So if you're trying to work out how much energy is supplied to the water, you need to know your mass of water. So if you chose 100 grams for instance, times specific heat capacity, well in water it's 4,200, times your temperature change. So if your ethanol, for instance, went from 18 up to 38, the temperature difference is 20. So you'd multiply all of those together so that you could find out how much energy was transferred to the water, and then you could actually make a conclusion and decide which one would be the best at transferring fuel.